Number 1, angle C is 84 degrees. Side B is 7.31, and side A is 13.88. Number 2, angle F is 39 degrees. Side E is 44.27. Side F is 30.50. Number 3, side Q is 22.59. Angle P is 31.99 degrees. And angle R is 62.01 degrees. Number 4, angle N is 96.35 degrees. Angle L is 53.85 degrees. And angle M is 29.80 degrees. Number 5, angle U is 18.22 degrees. Angle T is 138.78 degrees. And side T is 42.16 degrees. Number 6 has 2 triangles. In triangle 1, angle Y is 62.16 degrees. Angle Z is 64.84 degrees. And side Y is 33.22. In the second triangle, angle Y is 11.84 degrees. Angle Z is 115.16 degrees. And side Y is 7.71. Repeats or questions from this? Megan? Number 5, the side length for T is 42.16. You're welcome. Sabrina? No. Lindsay? Number 4? Sure. So in number 4, we're given 3 side lengths. The first thing I did was check to make sure a triangle is possible given these 3 side lengths. And I saw that since the sum of the legs is greater than the hypotenuse, a triangle is possible. So to solve this triangle in a side-side-side situation, I need to make sure I solve for the biggest angle first. The biggest angle, oops, that's supposed to be a 16 there. Yeeper deepers. The biggest side length, or biggest angle measure, is going to be the one opposite the biggest side length. So that's what I set up first. When I solve for n, I get the cosine inverse of 16 squared minus 13 squared minus 8 squared over negative 2 times 13 times 8. Now I type that into my calculator, I get 96.35 degrees. Once I have that angle, it doesn't matter which angle I solve for next. So what I did next is solve for angle L using the law of sines. So when I cross multiplied, divided, and took the sine inverse, I get that L is the sine inverse of 13 sine 96.35 over 16. And when I type that into my calculator, I get 53.85 degrees. And then to get angle M, I just did 180 minus L minus N. Raul? How did I know 6 was an ambiguous case? Okay. So we have angle X is 53 degrees, side X is 30 degrees, and then, side Z is 34 degrees. First thing I did was I observed that this is an SSA situation. Are you good with how I can tell that just by looking at it? Okay. The next thing I had to check was that the angle that was given was acute, which is what was going on there. And the next thing I had to do was check to see if the side length opposite my given angle was the shorter of the two side lengths, which is what's going on there. So this is an ambiguous case, so there could be 0, 1, or 2 triangles here. To determine how many triangles I would have, I'm going to use the law of sines. And when I get angle Z by itself, if this value is greater than 1, I have no triangles. If it's equal to 1, I have exactly 1 triangle. And if it's less than 1, I have 2 triangles. So if this is obtuse, if this angle here given is obtuse, then you have only 1 triangle. I guess you could have 0 triangles also as possible. If this side was shorter than that side, like if what you're given was like the hypotenuse isn't the longest side kind of thing. But, you know, if that's, you could have 1 or 0, I suppose. Does that make sense? Okay. Lindsay and Rachel, do we have something else?
Yeah, can you go over number?
3. Okay. So this I can see as a side angle side situation. Do you know how I can tell that? Okay. No. No? How do you know it's not side-side angle? So if all these letters are different, it's side angle side. Even if you have 2 sides in an angle, if all the labels are different, then it's side angle side. If one of the labels is the same, like we had up here where we have X and X, then it's side angle, or then it's side angle. Okay? All right. So first thing I'm going to do is solve for side Q using the law of cosines. So when I do that, I get 22.59. We good there? Okay. Now, to solve for my next angle, I have to be very careful here. When I apply the law of sines, I have to make sure I'm solving for the smallest of the 2 angles. In that case, I'm got to be solving for angle P. So when I cross multiply, divide, and take the sine inverse, I get 31.99 degrees. And then to solve for angle R, I can just do triangle sine. So remember, for a side situation, you find the biggest angle first. And for the side angle side, you find the smallest angle first. If you do not do those, you're going to get answers that either don't make sense or are giving you some errors. So you got to be careful about those. Okay? Anybody else? Olivia?
You said the values of the second triangle and number 6.
Sure. The values for the second triangle, angle Y is 11.84. Angle Z is 115.16. And side Y is 7.71. Alrighty then. On to the last section then, which is section 7.4. Which is all about the area of triangles. So we're going to be presented with a few area formulas in this section. We have one area formula already that you should remember from geometry. Does anybody remember the area formula for a triangle? 1/2 base times height. Great. What's the downside to this area formula? Yeah, if the triangle is not a right triangle, then the height is not one of the side lengths, right? So that's potentially a problem, particularly like in a real world scenario where maybe the height isn't readily available to us. So we're going to be presented with two formulas today, neither one of which requires the use of the height. The triangle. The first triangle is 1/2 BC sine A. And obviously there's three different versions of this, right? What's the way I remember this though? All three of the letters just are different, right? If I had 1/2 AB sine of C then, right? So just whatever letter, just so the letters are different. Everybody's okay with that? So to derive this formula, what I'm going to do is I'm just going to draw in the height here. And I know that I'm going to use side B as the base. That'll serve double duty there. Because remember, the height intersects the base at a 90-degree angle. So I have this, right? What I need to do, though, is find a way to rewrite H. So to do that, I'm going to look at this right triangle. Because this is a right triangle, I can use SOHCAHTOA. So I can say that sine of angle A is equal to opposite over hypotenuse. And when I solve for H, then I get H is C times sine A. And when I substitute that back into our area formula from geometry and simplify, I have the formula as desired. No big deal, right? Pretty easy derivation. The second formula we're going to look at today is called Heron's formula. And it says for S equal to A plus B plus C over 2, the area equals S times S minus A times S minus B times S minus C, all square rooted. We give S a special name. We call it the semi-perimeter. Okay. If you're interested in the derivation of this, it's in the lesson notes on the internet. I'm not going to go through it again here because it's pretty lengthy and I don't think it's really that informative. The thing that I'd want you to take away from it is that this Heron's formula is based on that previous area formula we just developed. So that's where kind of what our starting point would be, and we build out from there. So let's look at a couple of examples. So let's find the area for the triangle with angle A equal to 43 degrees, angle B equal to 10 millimeter, and angle C equal to 27 millimeter. Which of the area formulas should I use to do this? The first, second, or third? The second one. Good. So I can use the area formula A equals 1/2 side B times side C times sine of angle A. And that's all I need. I just type that into my calculator. And I get 92.07 millimeters squared. Is everybody relatively happy with that? So pretty straightforward there, right? Nothing tricky, nothing fancy going on. So next one, let's find the area of the triangle with side lengths A equals 5, B equals 8, and C equals 10 meters. Which of the three area formulas do you suppose we should use in this case? The third one. So I'm going to start by calculating my value for the semi-perimeter. When I do that, I get 11.5. If that was a non-terminating decimal, well, it'll always be a terminating decimal, I guess, since we're dividing by 2. I don't know why I was saying anything about it. All right, so I'll just plug this in. So I have S times S minus A times S minus B times S minus C, all square rooted. And for that, I get 19.81 meters squared when I type that into my calculator. Bless you. So just a word of caution. We've looked at, in our examples, a side angle side and a side situation. We can also calculate the areas for angle side angle and angle side situations, as well as side angle. Although in each of these situations, initially, you do not have enough information to apply any of these, any of the three formulas we've given to you here. So we'll need to either solve a side or angle, so in those situations where it doesn't look like you have enough information to use the formula, you're just going to have to use a law of sines or cosines first to solve for one of the other pieces that you would need to use the formula that you desire. So just as a heads up that can happen. That doesn't mean that the problem's impossible, that you can't calculate the area for it, but you might need to use one of these formulas first before you're able to plug in, before you have enough information to use the area formula. Okay? That's it for this section. So your last set of homework for this chapter is 23 through 30. Because this is the last section in chapter 7, we should probably talk about a test date. I'm going to propose to you what I would like to do, and if there's objections, we can talk about it. What I'd like to do is use our class time tomorrow as an opportunity for you guys to work on the review. I've posted, the review's been posted to the PowerSchool page for some time now, as well as the key for the review. You probably noticed it there at one point or another. And then on Thursday, I'd like to do the Chapter 7 test. I've also posted to PowerSchool on the test event on the calendar a description of what that test will look like. So I have 4 solving the triangle problems. I have 1 additional problem that has 2 triangles that I tell you has 2 triangles. I have 2 area problems, and then 2 kind of like story problem situations that are involving, either law of sines or cosines or the area. Raul? It was not a question that I listed as a test question. Olivia? No, I will specifically tell you the 2 triangle situation and ask you to solve that one. Okay? I don't think they're any harder than any of the other problems, to be honest with you. One of them, I even give you the picture.
Oh, so basically you draw our own picture so that you just say A equals B.
Kind of. It's not much more difficult. In fact, I don't think it's any more difficult, unless reading is an issue. And sometimes it is. I get it. Does anybody object to that schedule, though, that plan? I mean, it's certainly a situation where, like, if you want to bump it, we can bump it, but we're going to start new stuff on Thursday.
Wait, what is that?
Thursday. Thursday. I will give you the formulas on the test, so you don't have to memorize those. And hopefully it should be fairly straightforward, right? I don't think has been a tremendously challenging chapter for most of us. So we'll plan on that schedule, I guess, instead of